Okay, today we are going to talk about determining if two lines are parallel or perpendicular or possibly neither. Now, before we do that, let's talk about what parallel lines are. Two lines are parallel if they have the same slope and different y-intercepts. So parallel lines will never intersect. If you look at the current slide, all right, there's two ways to determine if lines are parallel. One is if we have the equations, all right, which we've learned that we should be able to recognize the slope in the equation. So what we have here, all right, is a slope of 3. What we have here is a slope of 3. So the only thing we need to do is verify that they do not have the same y-intercept. And we need to do this just because since we have multiple forms of a line, we could be talking about the same line. So if we convert this to slope-intercept form, we can then compare our intercepts. All right, so plus 4 minus 9. So we can see that these two lines have the same slopes, different y-intercepts. One has a y-intercept of -9, the other of +4. Therefore, those lines are parallel. Now, if we happen to have two lines graphically, we could do the same thing by finding two good points and looking at the rate of change graphically. So I can see that I go up 1 here, and I go over 5. So this has a slope of 1/5. Here it's very obvious that they do not have the same y-intercepts. We can see that this is +2 and this is -4. And then once again, we can see that we have a rate of change of up 1 and then over 5. All right, so you can see that those lines are in fact parallel and they do not intersect. Now, so when we look at things, we really look at them graphically and or analytically with equations here, and so you should be able to determine if lines are parallel from the equations and or a particular graph. All right, the other thing that we're going to talk about is perpendicular lines. Now, perpendicular lines have what we call opposite and reciprocal slopes, and I'll get to that in a little bit more depth in just 1 second. Now, perpendicular lines intersect at right angles or 90-degree angles. Now, if we look at the problems here, all right, once again, if we look at these two equations, when we say that the perpendicular lines are opposite and reciprocal, that means one slope has to be positive, the other one is negative. And remember, reciprocal means that if one slope is A over B, reciprocal of that would be B over A. So we can see that 2/3, all right, and -3/2 are opposite and reciprocals of one another. And when that occurs, all right, we're going to get two lines that intersect at right angles. Now, once again, if we have this with a graph, all right, we have to find the slopes from the graph. So if I look at point to point, so if I look here, this is down 1, and so that's -1, over 1, 2, and 3. So it appears that this line has a slope of, all right, -1/3. Now, if I go over to our second graph here, all right, and I'm going to come down here where we can see a little bit more clearly, I go up 3 and over 1. So this line has a slope of 3 over 1. So you can see that the two slopes are definitely opposite. One is positive, one is negative, and they are in fact reciprocals of one another. Now, so what this means for us is that we should be able to determine if two lines are parallel or perpendicular, or whether we have two equations and or a graph. So if we look at the next slide, all right, we want to determine if, all right, the two lines are parallel, perpendicular, or neither. And so the way we're going to do this is we're just going to analyze each equation to find the slopes and compare those. So if we look at example 1 here, all right, we can see, all right, these two lines have the same slope and different y-intercepts. Therefore, we would consider these to be parallel lines. All right, when we look here, it's very evident that they can't be parallel. They do not have the same slopes. All right, they can also not be perpendicular here because remember that while these slopes are reciprocals, they are not opposites. One is not positive, one is not negative. So these would neither be parallel or perpendicular. They're just two lines that happen to intersect, just not at a right angle. All right, if we look at number 3 here, our first slope is 5 over 1. All right, the next slope is -1/5. They are reciprocals and they are opposites. All right, so these are in fact perpendicular lines. Okay, now the next set of lines, all right, are dealing with our horizontal and vertical lines. Now, if we think about this, okay, if we remember x equals -1, that is a vertical line, all right, so it's going to go up and down. Y equals -9 is a horizontal line, all right. So if we have one vertical and one horizontal, those two will always be perpendicular to each other, all right. So vertical, horizontal, all right, and that would be perpendicular. All right, now if we look at number 5, y equals 17 would be a horizontal line like this. Y equals -9 would be a horizontal line like this. All right, we know that horizontal lines both have a slope or rate of change of 0. All right, so they have the same slopes. They would intersect at different y-intercepts, one at 17, one at -9. So these would be parallel lines. And then finally, example 6 here, x equals 8 and x equals -2. So x equals 8 would be a vertical line. X equals -2 would be to the left of that. It would also be vertical. And then once again, we get the railroad track look here, which means we do in fact have parallel lines. All right, so when we have equations in these forms, it should be very quick and easy to identify the slopes or the type of line and then determine if they are in fact parallel or perpendicular. All right, so what I'd like you to do right now is I have 6 more examples for you. I'd like you to pause the video. I would like you to identify the slopes and or types of lines and determine if they are parallel, perpendicular, or neither. Once you have finished, go ahead and restart the video, and we will check your answers. And I'm going to flip to those right now. Okay, so number 7, they have opposite reciprocal slopes, so they are in fact perpendicular. Number 8 would be neither. Number 9, they both have slopes of 1 and different y-intercepts, so they are parallel. Number 10, you have 2 horizontal lines, so they are parallel. In number 11, you have 1 horizontal and 1 vertical line, therefore they would be perpendicular. And then in number 12, you have 2 vertical lines once again, therefore those would be parallel. Now, the examples that we just looked at, all right, were simple in the fact that they were already in slope-intercept form, or they were horizontal vertical lines, so we could tell exactly what we had when we were looking at it. However, there are problems like you see here, all right, which we have equations in standard form. That could be both or one of the equations. So notice when we look at these, the slope is not as obvious as it was in the prior problems. So what we have to do is take each equation and we have to solve for y so that we can identify the slope for each equation. All right. So if you remember this process, what we're going to do is solve for y. So the first thing I'm going to do is subtract 15x from both sides. All right. I get -5y equals -15x plus 25. Now I'm going to divide by -5. All right. So I get y is equal to 3x minus 5. So I can see that my first equation is a linear function with a slope of 3 and a y-intercept of -5. So now I want to repeat this process with our second equation so that I can compare slopes and compare y-intercepts. All right, so once again, the first thing I'm going to do is move our x term to the right-hand side by subtracting 8x. All right, so let's bring everything down. And then I'm going to divide by -24 to completely solve for y. Now, when you do this, we always want to reduce our fraction. It makes things much simpler to compare if we always have our fractions in lowest terms. So a negative divided by negative is a positive. 8 divided by 24 is a positive 1/3. All right, and then 48 divided by -4 is -2. Okay, so if we compare the slopes of our two equations, they cannot be parallel because the slopes are not equal. All right, and while our slopes are reciprocals, they are not opposite, therefore our lines cannot be perpendicular. So this would be an example of a neither. Okay, let's look at one more of these together before I have you do some on your own. Okay, so once again, we're going to go through the same process. We want to solve for y for both equations, all right, and then compare the slopes and possibly the y-intercepts depending on what relationship we have. So let me just rewrite this right here. So once again, we're going to solve for y by adding the x term to the right-hand side here. All right, so that leaves us 10y equals 8x plus 40. And then I'm going to divide all three terms by 10. Okay, so now 8/10 is a reducible fraction. So if I divide, all right, by 2, all right, I would get 4/5 x and then plus 4. So our first line has a slope of 4/5 and a y-intercept of 4. Okay, so let's repeat this. All right. Oh, and there happens to be a typo here. This should be a 16x, so let's go ahead and correct that. 16x minus 20y equals to 160. So I'm going to subtract this 16x from both sides. All right, so negative 20y equals negative 16x plus 160. And then I'm going to divide by negative 20. All right, so now we get y equals, now once again, a negative divided by negative is a positive. 16/20ths, if I divide the numerator and denominator by 4, I get 4/5 x, and then 160 divided by negative 20 is negative 8. So when we look at our two equations, what we see is that they do have equal slopes and different y-intercepts. And because of this, we know that these two lines are in fact parallel. All right, so hopefully you have the hang of this. All right, so what I'd like you to do now is, here's the next example. I'd like you to pause, all right, the video at this time. I would like you to repeat the process that we've done in the last couple of examples to see if you can determine if these lines are parallel, perpendicular, or neither. Okay, so hopefully you solve both equations for y, and if you do so with the first equation, you can see that you get y equals 3/7 x minus 8. In the second equation, all right, you get y equals negative 7/3 x plus 5. All right, so now if we look at the slopes of those two lines, 3/7 and negative 7/3, we can see that they are opposite and reciprocal slopes. Therefore, they are in fact perpendicular. Okay, so one more example if you need it, all right, before we wrap up this video. So once again, go ahead and solve, all right, for y and get both equations in slope-intercept form to determine if these lines are parallel, perpendicular, or neither. Go ahead and pause the video and then restart it to compare your answer with the next slide. Okay, so when you solve for y in both of these, all right, the first equation comes up to be negative 2/3 x minus 4. The second equation, we get y equals negative 4/5 x minus 2. So you can see that these are neither parallel, they do not have the same slope, or perpendicular because the slopes are not opposite and reciprocal. All right, so then the lines are neither parallel or perpendicular. So this would be an example of the neither case. So two lines that intersect, just not at a right angle. All right, so that wraps up this video. All right, now you should be able to work on worksheet 4.3. All right, and I will see you in class.